Hello, today we are going to go over applying the counting principle and permutations. Let's just look at this first example here. It says a sporting goods store offers 3 types of snowboards. Those 3 types are an all-mountain, a freestyle, and a carving. And then 2 types of boots, soft and hybrid. Now, how many choices does the store offer for snowboarding equipment? Well, one way we can do this is draw a tree diagram. Now that tree diagram will outline pretty much everything that we would need, and show all the possible combinations or, that a person could choose for their snowboard or boots. So if we label these, the 3 types of snowboards, well, there's all mountain. Now I'm just going to abbreviate it. There is freestyle. And then there's carving. Now, there's those 3 different types of snowboards. Now, you have 2 different types of boots that you could choose. So, if you would pick the all mountain, you could have 2 boots that you could choose to buy. So, from there, you could have soft or hybrid. Same thing with freestyle. You could have soft or hybrid. And last, carving. Soft or hybrid. Now, from there, if you think about it, this would tell you how many different combinations or permutations that you could have of choices for if you pick one snowboard and 1 pair of boots. If you look here at the end, if you pick all mountain soft, there would be 1 choice. All mountain hybrid would be 2 choices. Your second choice. You get a freestyle snowboard and soft boots. That could be your 3rd choice. Freestyle and hybrid would be your 4th. And carving, you could have a soft and carving or a hybrid boot. So here there are 6 different choices that you could have when you go into a store to buy 1 snowboard and 1 pair of boots. So you could have 6 choices. Now, another way to think about that is using what's called the fundamental counting principle. The fundamental counting principle, and I'm going to go to the next slide here, is you can count your choices or use this principle by multiplying the number of ways each event can occur. Now, if we look back at the first example here, we have 3 different kinds of snowboards that we could choose, and then 2 different kinds of boots that we could choose. So if we multiplied these together, we would get our 6 choices. That's using the fundamental counting principle by multiplying all the options or the choices that we have or the ways that these events could occur to figure out our total. So if we look at this next example, let's say event A happens there's 5 possible ways. Event B happens 2 possible ways, and event C happens 4 possible ways. So if we multiply these together, A times B times C, that will equal our total. So if we just replace those numbers, 5 times 2 times 4, 5 times 2 is 10, 10 times 4 is 40. There could be 40 different ways that all events A, B, and C could happen. This next example says you are framing a picture. The frames are available in 12 different styles. Each style, though, is available in 55 different colors. Now you also want a blue mat board, which is available in 11 different shades of blue. How many different ways can you frame the picture? Now this is a problem where that tree diagram would not be the best way to go, because I would not want to have to put out 12 different styles, then 55 different arrows off of those, and then 11 off of those. So here's where we would use the fundamental counting principle by multiplying all of our possible options. So we have 12 frames, or 12 styles of frames, times 55 different colors, and then times the 11 different shades of blue. Multiply all those numbers together. 12 times 55 times 11. And we'd get 7,260 different ways that we could arrange a picture. Now, something a lot of people don't think about is that this can be seen in a lot of different states with the way they use their license plates. For instance, the standard configuration for a Texas license plate is one letter followed by 2 digits, then followed by 3 letters. So if we think about it, we have a letter, then a digit, a number, and 2 digits, and then 3 letters. So that's how a Texas license plate would be arranged: a letter, 2 numbers, and then 3 letters. How many different license plates are possible if letters and digits can be repeated? So think, how many letters do we have in the alphabet? Well, 26. Now, how many digits? How many numbers from 0 through 9? 10. Now, these numbers can be repeated, so I could have 10 numbers for the second digit, and then 26 letters for each one of the letters after the digits. We multiply those numbers together, we'd get 45,697,600 different ways that we could arrange that Texas license plate. Because license plates are individual, they're specific to a person's car, they're not repeated. So that's why we have so many different options, and we don't see those repeats. Now, the second part of this says how many different license plates are possible if the letters and digits cannot be repeated. Well, we start out with our first letter, 26 letters. Our first number, we have 10 total. Then our second digit, we cannot repeat that number that we use, so we have 1 less than that, so 9. And then we cannot repeat our next letters, so we used 1 already. We have 25 here. We've used 2 letters, so now we have 24. And we've used 3 letters, so now we have 23. We multiply those numbers together. And you see these numbers are lower than the last one, so we should get a lower number. There are 32,292,000 different ways that we could arrange those license plates. So in New York, the standard license plate is 3 letters followed by 4 numbers. So letter, 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 and then 4 numbers. So I'm going to use D for digit. How many different license plates are possible if letters and digits can be repeated? So we can use the same number for each time. So we have 26 letters times 26 letters times 26 letters. And then there's 10 digits from 0 through 9, so these will all be 10 because those numbers could be repeated. When we multiply those together, we get 175,760,000. Now the second part of that says how many different license plates are possible if letters and digits cannot be repeated. So 3 letters, we start out 26, then our next letter, we've used one, we cannot repeat it, so we have 25, and then 24. Then the same goes with our numbers. We have 10 to begin with. Well, we've already used one number, so we have one less than that for each one of those. When we multiply those together, we get 78,624,000. You see that once we say that a number cannot be repeated, then our number is less. The options we have, the events that could occur is less. Now, permutations. The permutations with probability is where the order of objects do matter. Okay, these orders matter. Now, whether we have 6 permutations of the letters A, B, and C. So, if A comes first here, then B and C, then what if we change the order of C and B? Now, what if we change the order and put B first? We'd have B, A, C, and B, C, A. And then what if we put C first? So we'd have C, A, B, and C, B, A. All these orderings of these objects matter. It's where it's at. So permutations, the order does matter. You can use the fundamental counting principle to find the number of permutations of A, B, and C. There are 3 choices for the first letter, and after that there are 2 choices for the second, and finally after the first 2 have been chosen, there's only 1 choice left. So we can use that fundamental counting principle, 3 times 2 times 1 to equal 6, because the order does matter. Also with permutations, there's the factorial. Now some of you may have seen it. It's the exclamation point. Well, in math, that is called the factorial symbol. Factorial means you multiply your number by all the numbers below it. So 5 factorial would be 5 times 4 times 3 times 2 times 1, which when we multiply those together we get 120. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1, and we would get 5,040. 15 factorial would be 15 and times all the numbers less than it, and so on. And 19 factorial would be 19 times 18 times 17, and so on. You just keep multiplying them out. There is a factorial button, okay, on your calculators. All you do is type, on a TI-30, you would type the number, then hit the PRB, the probability, and then scroll to the factorial button. So there is that button in all calculators. Permutations. 10 teams are competing in the final round of the Olympic 4-person bobsledding competition. And how many different ways can the bobsledding teams finish the competition, assuming there are no ties? So if there are 10 teams, then it matters what order they would come in. Team A could come in first, then Team B. Or Team B could come in first, then Team A, and so on. So the order does matter. So we could use the factorial button. So 10 factorial, that would multiply all of our numbers together to get 3,628,800 different ways that 10 teams could come in order. Now, B says, in how many different ways can 3 of the bobsledding teams finish first, second, and third? Well, only the top 3. So we'd do 10 times 9 times 8. We want to only know the top 3 teams. So there's 10 teams for first, then after that there'd be 9 teams for second and 8 teams for third, and we get 720 different ways that those 10 teams could finish. Now there is a permutations button where the number of permutations of these objects taken from a group is denoted by NPR. N is the total number of objects, and R is the top objects taken at one time. So we can use this button out of the calculator.